Good morning and once again welcome to my YouTube channel Maths with Ease by Mr. Kamotho. And in this video we explain example 5 of handling data 5. And we are told that a box contains 3 letter tiles as shown. We have A, B, one tile showing, 2 tiles showing letter A and 1 tile showing letter B. A tile is chosen at random from the box and then replaced. This is a keyword in this question, replaced. And I'll explain. A second tile is now chosen at random from the box and then returned. Part A of the question, draw a tree diagram to show the probabilities. And part B, work out the probability that at least one A, at least, another keyword, one A is chosen. We will just have a tree diagram here. We are likely to get tile that has A or B. The probability of getting tile A is 2 out of 3, 1 out of 3. That is first picking. And then, whatever we have picked, we replaced it back in the box. It means the box contains exactly the number of items that it did contain even before the experiment started. That means if we picked A, we have noted we have picked A and we have returned it. So the tiles are still the way they were. We still have 2 A's and 1 B. So in the second picking, we are meeting the tiles. It's like they are not disturbed at all. They are exactly the way they were in the beginning of the experiment. So we are likely to go for the second picking and this time also get an A or get a B. And we are likely to go after picking B, we can get an A or B. So since the tiles were not altered, we still have 2 out of the total 3 of A, 1 out of the total 3 of B, 2 out of the total 3 of A, 1 out of the total 3 of B. And that's what we have. Now that is our tree diagram and that is part A of our question. Replaced means the items are not disturbed. They are exactly the way they are because we returned what we picked. Part B. Work out the probability that at least one A is chosen. At least means we can have 1A or both of them could be A. But at least it means the least number of A's is 1. At least 1A. At least 1A. So whatever we pick, we must not miss an A in both pickings. So AA is acceptable. AB, this is AB, which is acceptable also because we have an A. BA is also acceptable, but BB is not acceptable because we don't have any A there. So at least one A means we can follow this route 2, 3, 2, 3, 2, 3, and another A and A, or another route now AB, which means 2, 3, and now multiplied by a third, or another route now B, a third times A, 2, 3. All these are possible outcomes. And as you can see, we have 4 out of 9 plus 2 out of 9 plus 2 out of 9, which is basically 8 out of 9. That is the answer to that question. Alternatively, I may want to explain a different approach. Alternatively, we may have a different approach to this question. Since we are talking of at least one A, what we don't want is any B. What we don't want is all B. All of them should not be B, or both of them should not be B. So we know, because we know the probability of picking at least one A, it means the probability of picking the probability of not picking both B's. And because we know the probability of picking at least one A is 1 minus the probability of picking both B's. This is what we don't want to see. And of course, it goes without saying, the probability of at least one A is 1 or minus the probability of picking both B's is a third times a third, because you are talking about this root which is not acceptable. A third times a third, which is 1 minus 1 over 9, which is basically what we had here, 8 out of 9. Both answers are acceptable and they are correct, so you can give it an approach. Thank you. Follow me and subscribe, and of course share so that we can learn together. Let us meet in the next video.